Hi class, how are you today? Wow, that's amazing. The learning target for today is to be able to factor quadratic expressions when a does not equal 1. So in the last video we went over when a equals 1. So now these are a bit different. This is when a does not equal 1. The scale, you're a 3 if you can factor quadratic expressions when a does not equal 1. You're a 2 if you can factor quadratic expressions when a does not equal 1 and the other terms are divisible by a. So that means you can pull out a GCF like we did a couple videos ago. You're a 1 if you can factor quadratic expressions when a equals 1. So if you can do what we did in the last video. And you're at 0 if you cannot factor any quadratic expressions. Let's get started. Okay, so just like I mentioned in the scale, one way to do this is to factor out a GCF, and then it will be down to where a equals 1, and then you can factor it just like we did last time. So these two problems are just like that. So let's check it out. So the first thing you always want to do when you factor is see if you can pull out a GCF. Can you factor something out of every term? So in this first one here, 3, 6, and 45 are all divisible by 3. So we can factor out a 3. And then left on the inside, we have x squared plus 2x, because 6 divided by 3 is 2, minus 15, because 45 divided by 3 is 15. And now this looks, if you ignore the 3 in front, just like what we were doing last time. So we say, okay, what are the factor pairs of negative 15? And one good thing to always look at is this middle sign here. If it's a plus, that means the positive number is going to be the bigger one. So that means we've got negative 1 and 15, negative 3 and 5. Of those two, it's this one here that works. So we say x minus 3, x plus 5. And that 3 from before comes right back. And this is our answer. So it's got to be factored completely. So we need to make sure to factor out that 3 at the beginning and then continue to factor. And this will make it much easier on you because if you don't, you'd have to factor it in the way we do in the nets method, which takes a bit longer. So this is actually the way you always want to go if you are able to factor out a GCF. So for this next one, very similarly, 4, 12, and 8 can all be divided by 4. So we throw the 4 out in front, and we're left with x squared plus 3x plus 2. And here the only factor we have is 1 times 2. That's the only factor pair. So that means x plus 1, x plus 2. And yes, you do have to check to make sure 1 plus 2 equals 3. If that was, say, a 4 in the middle, and this was still the 2, that would not be factorable. So in this case, we've got 1 plus 2 is 3, so we factor it out, and then throw the 4 in front. That 4 needs to stay there. Don't forget about it, even though you don't use it until the end, but it's still got to be there. And that's our answer. All right, there are actually two methods for factoring quadratic expressions when a does not equal 1. And I'm going to show you both of them today. One, a lot of people find quicker, and it can be quicker a lot of the time, but also there could be a lot of guess and check going on that could take forever. And so I also have a second method that consistently takes the same amount of time no matter what the problem is. So with this first method I'm going to show you, we're going to have problems that could be very difficult for this kind of method because there are so many factors. But for the next method, really, unless the factors get too bad, it's going to be consistently the same amount of work every time. But this way could be quicker for a lot of people in a lot of situations. So the first step is just like we did when a equals 1. We're going to look at the factors of 15, the n number, but also the first number, 2. So the factors of 15 are 1 and 15, and 3 and 5. And the factors of 2 are 2 and 1. And so now we're going to set up it in factored form, but missing some things. So we're going to have an x in both sets of parentheses. And then for the beginning, we have 2 and 1. So that part's going to be easy. We have a 2 here and a 1 here. Or instead, we can just get rid of this and just call it x. So we have 2x in one, x in the other. And also, just like in the last one, we can see that both positive for last term and middle term, so we're going to have plus signs here. And then we need to do some quick multiplication and see which match. So what that means is we need to figure out of these numbers here, which pair are we going to use and which numbers are they going to multiply by. So we could try 2 times 1 and 1 times 15. So 2 times 1 plus 1 times 15. We could also do it in the other direction. We could do 2 times 15 and 1 times 2. And we could do the same thing for the next one. 2 times 3 plus 1 times 5, or 2 times 5 plus 1 times 3. And those are all the possible combinations. You don't always have to write them all out, but I'm doing this to show it work. So, and then you see which ones work. Well, there will be only one specifically that works, though. So, here we've got 2 plus 15, which is 17. And again, we're looking for it becoming the middle number, which is 13. So here we've got 30 plus 2, which is 32. We've got 6 plus 5, which is 11. And we've got 10 plus 3, which is 13. And so it's the bottom one that works. So we know that 2 needs to multiply by 5, and 1 needs to multiply by 3. So 2 and 5 need to be in opposite parentheses. So 2 is on the left, so 5 will be over here on the right. And that means 3 is in the other spot. And this is our answer. On this next one, it's going to be the same strategy. So factors of 8, which are 1 and 8, 2 and 4. But notice we've got plus and then minus in the middle there. So we're actually dealing with all negatives. So again, the last sign is plus, the middle sign is minus, so we're dealing with all negatives. And then for 3, we've got 3 times 1. So from here, we've got 3x and x. And we need to see which combination works. If you're quick and can do this without writing it down and just kind of mental math it, that's perfectly fine, but I'm going to write it out so we can see it done. So we've got 3 times negative 1 plus 1 times negative 8. We've got 3 times negative 8 plus 1 times negative 1. We've got 3 times negative 2 plus 1 times negative 4. And we've got 3 times negative 4 plus 1 times negative 2. 3 times negative 1 is negative 3, plus 1 times negative 8 is negative 8, which will give us negative 11. Next one, we've got negative 24 plus negative 1, which will give us negative 25. In the next one, we've got negative 6 plus negative 4, which will give us negative 10. And in the last one, we've got negative 12 plus negative 2, which is negative 14. So just as before, the 3 needs to multiply by the negative 4, so it needs to be in the opposite set of parentheses for it to be able to multiply with it. And that means the negative 2 will be in the first set. And that's our answer. Okay, so now I'm going to do the exact same problems, but this time I'm going to use the other method I talked about. First thing we're going to do is, instead of just looking at the numbers that multiply to give us c, we need to look at the numbers that multiply to give us a times c. So we're looking for a times c, which in this case is 2 times 15, which is 30. So which two numbers will multiply to 30 that will add to 13? It's still b, it's still the same thing we were adding to. This time we're looking at a times c. So for 30, we have 1 times 30, 2 times 15, 3 times 10, and right there I see 3 plus 10 is 13, so this is the one that we're looking for. So now we rewrite this polynomial, and instead of factoring it, we have a few more steps to go. We have to rewrite it. We still have the 2x squared, but now we're splitting up this middle term. We're splitting up 13x into 3x plus 10x. And then the plus 15 is there as well. So we're just splitting up 13x into 3x plus 10x. We haven't changed the value at all. We're just splitting it up, and now we're going to factor using a method called grouping. So what we're going to do is we're going to put the first two terms in parentheses together and the last two terms in parentheses together. And we're going to factor out what's common. We're going to factor out the GCF of both of these groups. So in the first two terms, 2 and 3 don't have a GCF. So the only thing we can factor out is an x. Because we have x squared and we have x, so we can take out an x. So we have x, and then in parentheses we are left with 2x plus 3. And then we have this plus here. And then in the second set of terms, we have 10x plus 15. So 10 and 15 have a GCF of 5. And we can't take out any x's because 15 doesn't have an x. So we're left with 2x plus 3. And when you do this, one thing that will always happen, this will happen every time, is that we have 2x plus 3 here and 2x plus 3 here. We will always, always, always have the same term in parentheses on both. If you don't, then something went wrong somewhere. And that's one way that within your work you can see whether you did it right or not, because if you get a different term, then you did something wrong, and something went wrong and you just need to go back and fix it. So, since we have 2x plus 3 and 2x plus 3, we can factor out that 2x plus 3. So it's just like factoring out any other term, but this time it's a binomial we're factoring out. So it can get a little bit confusing. So we have 2x plus 3, and then when we get rid of the 2x plus 3, what we have left is what's in the other set of parentheses. So if we get rid of this 2x plus 3 and get rid of this 2x plus 3, what we have left is x plus 5. So x plus 5. And this is our answer. And just like in the past, you can always multiply this out to make sure you did it right, but that is our answer. All right, for the second one, it's going to be a lot of the same stuff, but there's one thing that we'll need to pay attention to. But we follow the same steps. So we're looking for a times c, so we're going to take 24 and find the factor pairs of 24. Do remember that we have a negative here. So that means all of our factors are going to be negative because this was positive, so they're going to be the same. So we're going to have -1 and -24, -2 and -12. I just always like going up from 1 and just keep going, and then just keep going until I find one that works. And in this case, I found one that works pretty early, -2 and -12. So I split that up. So I have 3x squared minus 2x minus 12x plus 8. And now I group. However, this is where the change goes. Notice I have a negative here. Before I group, I need to change this into a plus. So I need to change this into plus negative 12x. And then I can put the parentheses around. So that is a negative 12x. Then I factor out the x because 3 and 2 don't have a GCF, so I factor out an x. And what's left inside is 3x minus 2. And then notice the negative is in front. Whenever you have that negative in front, you need to factor out the negative. So we want this back into minus. So we're going to factor out the negative, and we're factoring out 12 and 8 have a GCF of 4, so -4. So -12 divided by -4 is 3x, and then 8 divided by -4 is -2. Make sure you bring that negative along with it. It's factoring out of both. And that makes it so we have 3x minus 2 on both of these. If you're ever doing it and you don't end up with exactly the same one in both parentheses, then maybe you went wrong in that sign. Maybe you forgot to pull it out. Maybe you forgot to factor it out of both. Something. So just always make sure to check that. Then We factor out the 3x minus 2, and what's left is everything that's not in parentheses, x minus 4. And as always, you can always multiply these out to make sure you did it right, but that is the answer. All right, now time for the sponge activity. 2 problems today. Number 1, factor 2x squared minus 10x plus 12 completely. So factor out any GCFs, anything like that, and then factor it like normal. And then number 2, 2x squared plus 7x plus 6. If you can factor out any GCFs, do that, and then factor how I went along today. As always, don't forget to take notes on the entire lesson, take pictures of everything, submit it all to Google Classroom, and have a good night.